Hi, everyone, and welcome to the second lesson of the online SHSAT math course. This is going to be reviewing the constant of proportionality. So if you have no idea what that means or you're slightly familiar, no worries. I'm going to take you through a quick lesson demonstrating what it is, and then I'm going to show you how to solve questions and how to recognize the questions in the SHSAT that are testing this concept. So without further ado, let's go ahead and get started. So I'm going to just minimize my screen here so you can kind of see what we're working through. So the first example I'm going to use is baking a cake. Let's say you find a recipe and it says that in order to bake this cake, for every 2 cups of flour, you're going to need 3 eggs. So what this means for us is that now if we want to do maybe make more cakes, we need to think about, okay, how many cups of flour? We're obviously going to increase that, but then we also have to increase the number of eggs, but by what amount? And that's where the constant proportionality comes into play, because it makes sure that the ratio between y and x stays constant as we increase either one, in order to make sure that, the outcome stays the way we'd like it to. So in the table, I'm going to write on one side the cups. We'll do cups of flour. And then the other column is going to be the number of eggs we use. So we can see from the first example they gave us that 2 cups of flour, we're going to need 3 eggs. And this is if we want to make 1 cake. But what if we want to make 3 cakes? So if we want to make 3 cakes, we know that we're going to have to do 3 times the amount of flour. So on this side, we're going to kind of like just multiply by 3. And that just would get us 6 cups of flour. But then how many eggs should we use if we're using 6 cups of flour? Now that's where we have to find the constant of proportionality. And in order to find that ratio between the number of eggs and cups of flour, or in this case, if we labeled cups of flour X, we can also label the number of eggs Y. So we want to find what Y divided by X is in order to find that ratio between them. So that way we can multiply the cups of flour by that constant in order to find the number of eggs. It might make a little bit more sense in just a moment. So over here, if I want to do y over x, that's equal to 3 over 2. And then I can just go ahead and multiply 6 by 3 over 2. And if we solve that out on the side, 3 over 2 times 6 is going to get us a value of 9. So now over here, we know that the number of eggs for 6 cups of flour is 9. And that also makes sense because we could have also just multiplied 3 by 3. But I wanted to solve it this way because that's how you're going to approach most of the SHSAT questions that ask you to identify the constant of proportionality in a table. So it's important to recognize the relationship in a table. Before we move into the graph and equation, I want to talk more, about the equation before we move into other parts. So over here, we see that it says y equals kx. So k demonstrates the amount that y increases every time x increases by 1 unit. So I'll just quickly write that out, that k is actually the constant of proportionality. That's the variable we use to represent that. And this, if we were to interpret what it means, it would be the amount y changes. So, it can either increase or decrease. In this case, we're typically going to see positive constant of proportionality values in the questions. So the amount y changes for every 1 unit increase in x. So the way we can interpret that in the table over here is that if we were to interpret this, for each 1 cup increase in flour, our x variable, the number of eggs used increases by 3 halves, or 1.5 eggs. So you would add 1.5 eggs for each additional cup of flour used here. Okay, now let's move into how does this look on a graph. So I'm going to use the same variables for cups of flour and eggs. So as always, we have on the x-axis, and the x-axis is going to be the horizontal one, the y-axis is vertical. And then I'm going to label it. X is going to be the flour, and this is going to be the eggs for the y, like that. Okay, perfect. So for every proportional relationship, the proportional relationships all use the same equation, by the way. So we're always going to have the graph line start in the origin, like that. The origin is basically that coordinate point that's 0, 0. When x is 0, y is also going to be 0. And we know this is the case because even in the equation that I just showed you, y equals kx, when x is equal to 0, so when x is equal to 0 over here, k times 0, no matter what value of k you have, y is also going to be 0 as well. And then from there, if we wanted to graph this out, we would think, okay, if x is equal to 1, this is going to be for the eggs. Oh, I think we're kind of cut off here, so I'll just move this a little bit. Y is going to be equal to 3 halves. And we can find all these coordinate points by actually plugging. So we found that in the last problem, we found that the k value is equal to 3 halves x. So if we wanted to find, let's say the next thing we want to do is, okay, if x is 4, if we had 4 cups of flour, how many eggs should we use? Then we would get 12 over 2 is equal to 6 if we multiply that out. So if we wanted to continue doing this, it would be like 4, if x is equal to 4, meaning if we used 4 cups of flour, then y is going to be equal to 6. And we should see that as we plot this, there should always be a straight line. Now that one looks a little bit wonky, but that's just because I am, freestyling it by hand drawing. So the things that you want to look out for in a table and a graph. So first, for the table, you want to make sure, I'll write this in dark blue, you want to make sure that y in each row, y over x is the same, because that means k is the same throughout, which is why this equation works. And then for the graph, you want to make sure line passes the origin, which is that 0, 0 coordinate. And the second thing you want to see is make sure the line is perfectly straight. And that's how you know you have a proportional relationship. Oh, I realize you can't see that bottom part. I think I'm running out of space. So that's the one thing we're checking in the table, and the 2 things we're checking in the graph. And if I haven't already defined this, because I realized I didn't really point that out super explicitly, the formula for finding k is equal to y over x. So that's how we always find the value of k if it's not given immediately. Now for the equation, we already kind of went over this, but the one thing you want to look at here is making sure no b term. So the reason why I say no b term is that typically more complex equations that include a y-intercept that doesn't pass through the origin is equal to y equals kx plus b. But in this case, we shouldn't have a b term, because then that represents, that I guess indicates to us that it does not pass through the origin if we were to graph it out. So we should not have this. Yeah, so we're always looking for the y equals kx equation. And once again, just one last thing I wanted to mention, as I labeled already before, it's just that k is equal to y over x. And that makes sense because, if we want to prove that's true, y equals kx, y equals y over x times x, which should just get us y equals y. So we know that gets us the same value. Okay, I think my face was blocking part of that. Okay, perfect. I'm going to zoom out so you can see all the work we just did. And I broke this up into 3 sections: table, graph, and equation, because that's the way it's going to be expressed in the SHSAT questions. So without further ado, let's start working on the first section. And remember that as I go through them, pause where you need to, try doing it by yourself first, and then you can come back and we'll do it together. Okay. So these questions are all about us finding k. We're finding that proportional constant. I'm going to read this out loud. So, and I'll also highlight as I go in case I think anything's important. Okay. An ice cream shop sells 16 cups of ice for $48 and 4 cups for $12. There is a proportional relationship between the number of cups of ice cream and the cost. What is the constant of proportionality for this relationship? So they gave us 2 data points essentially, and we have 2 units. So my mind goes to creating a table. So if I were to write this out, one side will be the cups of ice cream and the other side will be the amount it costs. So cups, I'm going to write this here, cups of ice cream and the amount of money. And then it says it costs for 16 cups of ice cream, it costs 48. And then for 4 cups, it costs 12. Okay, great. So now we have them separated based on the units. And as we just went over, in order to find the constant of proportionality in a table, we need to divide the y value over the x value. So in this case, there's no explicit y and x value. But if we look at the answer choices, you can see that they alternate between per dollar, per cup, per dollar, per cup. Now, I think it's usually more natural to measure the price per cup instead of the number of cups you can get per dollar. So my first strategy is just going to be checking, do any of the answer choices match it when, the amount of money is y and this is x. So over here, we have y equals 48 when x is equal to 16. And we know k is equal, I realized I need to come here. Okay, great. K is equal to y over x, which is 48 over 16. And that gets you 3. And that represents $3 per cup. Because we just did, if we were to label the units, we just did dollars over cups. So yeah, this is $3 per cup. And that matches, let's see if it matches any of the answer choices. $3 per cup. Okay, I see that in answer choice F. So F is the correct answer. Okay, great. I hope you had a very strong start, but don't worry, we have more practice, so just follow along here. Okay, second question. The table below shows the number of cups of red paint and blue paint used to make a purple paint mixture. So they show us the table over here. Based on the relationship between the number of cups of red paint and the number of cups of blue paint, what is the value of y? So y is the missing value here. Now, what I'm thinking automatically is, okay, I want to find that constant of proportionality, which is k. And I guess they label, in this case, these are like the y values and these are the x values. So I'm just going to also label that y and x. And I'm going to find the constant proportionality. So k is equal to y over x. And I'll take one of the data points. We don't need to use multiple here because they already tell us that it is a proportional relationship. Or they don't really explicitly say that, but we just know that if we are using the same ratio to find y, then it should be. So I'll use 6 over 4. And that simplifies to 3 over 2. So then from there, if k is equal to 3 over 2, in order to find the y value, we know the equation y is equal to kx. So k is equal to 3 over 2. And then x is equal to 11, which was already given to us over here. And then if we multiply those, let me scroll down a little bit. Okay, if we multiply those, we get 33 over 2, which gets us the answer choice of G, 16.5. Great. Now, question 91. A recipe uses 2/3 cup of sugar for every 1 1/4 cups of flour. A cook wants to increase the recipe. How many cups of sugar are needed for each cup of flour? So basically, I guess like different units, but the same. Honestly, it's very similar to the original example I used. So if we were to set up a table, on the left-hand side, I'll do cups of sugar, and then the right side will be cups of flour. Now, it doesn't really matter which side you put these on because you're going to get the same answer because it's the same relationship. But based on the context of the question, I just set it up this way for now, just off the top of my head. So it's not like the right way, but just make sure that you have both sides of the table separated by units. So on the left-hand side, we have 2/3 cup of sugar. So I'm just going to write down these units for every 1 1/4 cup of flour. Okay. And now we want to find if it says how many cups of sugar. So we're kind of like finding this missing value. How many cups of sugar are needed for each cup of flour? So 1 cup of flour, we want to know how many cups of sugar are we trying to get? Do we need for each one? So in order to find that information, we can use the same process. Let's say that the cups of flour is equal to y and the cups of sugar is equal to x. We're thinking, okay, in order to find that k value, so x times k would get you the cups of flour. We need to solve it by doing k is equal to y over x. So we'll use the data they already gave us, which is 1 1/4 divided by 2/3. And now we want to make sure that we rewrite this from a mixed number to an improper fraction. So 1 1/4 is equal to 5 over 4 all over 2/3, which is also equal to 5 over 4 times 3 over 2. And then when you multiply all of that out, you're going to get 15 over 8. Okay, so the constant of proportionality, and based on the way that I solved it, you may have done it a little bit of a different way, and maybe this is like a flip fraction for you, but it's 15 over 8. So that means x times 15 over 8 gets you 1. And if we were to write that out in an equation, that means, okay, x times 15 over 8 equals 1. So in order to find the value of x, we would need to multiply by the reciprocal. So we would do times 8 over 15. And this is the same thing as dividing by 15 over 8, by the way. And so we would get x is equal to 8 over 15, which matches answer choice A. So even if you flipped which columns each unit went in, you should have gotten the same answer, hopefully. I think I actually took the longer route by doing that. But anyways, I just chose something and went with it. Okay, now this question kind of is on its own. It's using a graph. So think back to that example or like the original demo or lesson where you think about the two things a graph needs in order to be classified as a proportional relationship. First, the line needs to pass through the origin, and it needs to be a straight line. Okay. So this graph shows y, the weight of a pole of length x. So when the length of the pole is certain feet, how wide is the pole? they're proportional. And the reason why I can tell that they're proportional is that first, it passes through the origin over here. And then there's also that straight line. Now it's asking what is represented by the point with coordinates 1, 4. So if you're familiar with coordinate points, you would know that this is x, y. And that means that if we were to break this down, when x equals 1 foot, y equals 4 ounces of weight. Oh, weight, not width. I think before I said width. Now let's see what this, what answer choices can we immediately eliminate. So it says the y-intercept is 4. Wrong, because the y-intercept is the value of y when x is 0, and in this case, x is 1. Also, you can see that the line doesn't start from 4, so B is incorrect. It says a pole that is 4 feet long weighs 1 ounce. You can see that they flipped the units here. The length increases 4 feet for each 1 ounce of weight. It's actually opposite. So every foot, right, because it's per 1 unit increase in x. So it's increasing the length by 1, increases the weight by 4. So that makes A, the unit rate is 4 ounces per foot, the correct answer. Okay, now we're going to look at questions that describe the relationship between x and y using the constant proportionality equation, which, if you don't remember, is y equals kx. Okay, now it says, for the first one here, a hiker plans on hiking 17 miles in 3 days. Which equation represents the relationship between the number of days hiked x and the number of miles traveled y? So they identify which variable corresponds to which unit, which is great. Remember, the equation is y equals kx, and in order to find k, we know that k is equal to y divided by x, which in this case, the y value is miles traveled, 17, and the number of days hiked is x. So it's going to be 17 over 3. And then if we were to solve this, let's see, or if we were to plug this back in, it would be y is equal to 17 over 3x, which gets us answer choice C. Perfect. And that looks correct because if we plugged, 3 into x, you would get 17 as the answer. But usually you don't have enough time in the SHSAT to go back and check. But that is one way to test it, is just plugging in the original values and making sure that the equation is true. Okay, question 76. Serena was studying the number of water stations for different lengths of races. The table below shows the data she collected. So we have the length of the race on the left side and then the number of water stations on the right side. Which equation represents the relationship between the length of the race, x miles, and the number of water stations, y? So once again, we can see that the answer in equation form, so it's y equals kx. The only thing we don't know is what k is equal to. So using the same exact strategy, in order to find k, we need to do y divided by x. And it says the number of water stations is y, and this is x. So we can do k is equal to, let's do the simplest one, which is just 2 over 3. I'm using this data point here, because the relationship should be the same regardless of which data point you use. But in this case, 2 over 3, you don't have to simplify this. So I got k equals 2 over 3. And if I were to plug that back in, you would get y equals 2 over 3x, which gets us answer choice. Oh, you couldn't see that, but yeah, it gets us answer choice E. Now, why do I know it can't be G or H? So as we said before, the y-intercept is 0. And this over here, by adding or subtracting something to the x term, it demonstrates what the y-intercept is. And yeah, if this was not a proportional relationship, maybe that might be true. But in this case, because it is a proportional relationship, because, I mean, if you were to test it's a proportional relationship, you could see that 12 times, that really 2/3 gets you 8, and then 18 times 2/3 gets you 12. So since it is proportional, as we proved by multiplying by the constant and getting the y value, we know that g and h cannot make sense here. Okay, now we're on to the last part, which is interpreting. I think interpreting can be a little bit more tricky than students realize because it does require a deeper understanding of the material. So question 109, a farmer has 100 apples and will eat 2 apples per day. Is there a proportional relationship between the numbers of apples remaining and the number of days that have passed? So I think it might be easiest to figure this out by actually drawing a table demonstrating the number of days passed and the number of apples remaining. So if we write this out, we can do number of days passed and then the apples remaining. So the farmer on day, let's say day 0, has 100 apples. And then the first day, there are 2 apples that he ate or she ate, the farmer ate, and that leaves us with 98 apples because we're subtracting 2 apples each time. So even though it might be easy to be like, okay, we are passing one day, we're removing 2 constantly. Let's just keep going here for a second. Let's do a third point. So after 2 days, now there's 96 apples because they ate another 2. Okay. So remember that in order to have a proportional relationship, any of, you should be able to multiply x, which in this case, I would just define it as number of days, and y, apples remaining, by the same number to get the y value. So x times the same constant should get you the same y value. Now in this case, in order to get 98 apples, like the apples remaining, it's 1 times 98. Whereas for after 2 days, it's times 2 times 48, I believe, gets you 96. So that's the first red flag, is that it's not constant throughout all the data points. Yeah. Now, the second red flag is that on the number of days when it's 0, when x is equal to 0, y should also be 0, right? Because we want to have that 0, 0 origin coordinate point. But in this case, there's actually a y-intercept of 100. And so off the bat, we know that the answer choice is going to be no. But now let's look at the reasoning. It says, for B, it says, okay, for A, it says no because the relationship does not include 99 as a number of apples. That doesn't matter. The y value, whether the y value is 2, 5, 6, 7, it doesn't exactly matter whether 99 is included in that data set. What does matter is what B says, because the ordered pair 0, 0, which is the origin, is not part of the relationship. That's what makes it, that's what indicates that this is not a proportional relationship. So we would get B as the correct answer here. Okay, final 2 questions. You've been with me for quite a while, so we're almost done the final stretch. A graph shows the proportional relationship between the number of test questions a student gets correct, X, and the student's test score, Y. The ordered pair 1 and 5/4 is on the graph. What does the Y coordinate of the ordered pair represent in this relationship? So I'm just going to look at the units again. We know that X is the number of test questions the student gets correct, and the student's test score is Y. The ordered pair, let's say X is equal to 1 question correct, and then Y is equal to 5/4 test score increase, or just a test score, 5 or 1 1/4 test score. What does that represent? Okay, so what that's demonstrating to me is the original interpretation that we wrote, which is that, first of all, we can find what K is, the constant proportionality. K is equal to Y over X, which is equal to 5/4 over 1, which is equal to 5/4. Now, what does that demonstrate here? let's see if I can kind of find some space to write that out. I'll kind of zoom out a little bit. So that means that a student getting one more question correct increases their test score by 5/4 points. Okay. So now let's look at the answer choices to see what closely matches that. The test will last 1.25 hours. That's not correct. And keep in mind that 5/4 and 1.25 are the same thing. So just bear that in mind. That's not correct. C says an average student can answer 5 questions in 4 minutes. It's not about correct because they don't mention time in either the X or Y value variables. And then it says a student who answers 5 questions correctly will earn 4 points. No. So let's actually test that out. Let's test it out. Y equals kx, and we know that y is equal to 5/4 x. Now let's test that. A student who answers 5 questions correctly, which is x, so times 5, what is the value of y, the amount of points they get? Well, if we solve that out, it's equal to 25/4. So that is roughly equal to almost 6, I would say, about 6, which is not what D says. So B is the correct answer because, yes, each test question is worth, right? Like getting one more test question correct increases their score by 5/4 points, which matches this. I hope that explanation helped a little bit. It was definitely a little bit of a trickier question, but that's why it's important to have that conceptual foundation. Okay, very, very last question, and then I can stop yapping. Amazing. A graph shows the relationship between the number of gallons of water, Y, that has been added to a tank and the number of hours, X, that water has been added to the tank at a constant rate. What does the ordered pair 3/24 represent? So once again, I think it's easiest just to kind of write it out that when X is equal to 3, we know the number of hours. So when that X is equal to 3 hours, Y is going to be equal to, it's the number of gallons of water. So the way I would interpret this is that after 3 hours, 24 gallons of water is added. So what matches that? Yeah, it's answer choice G. 24 gallons of water added in 3 hours over here. Okay, well, let's just zoom out and look at all the work we have done today. Wow, incredible. If you want the follow along worksheet, make sure to click the free link in the bio so that way you can write it out as we go. But yeah, thank you so much for joining me, and I'll catch you lesson 3. I'm going to take you through literally every topic in the SHSAT. So come test day, you know how to recognize what certain questions are asking from you, and you're not mixing up any vocabulary terms and not making any silly mistakes. Yeah, thank you for joining me, and I'm excited to be part of your SHSAT journey. See you in the next one. Bye.